What's up, guys? It is Monday, April 20th. I hope everyone had a great weekend. Today we're going to get into 2.2, where we're going to actually start talking about what transformations are, and we're going to talk about a specific one today called a translation. All right. So let's read some vocab quick so we can understand what we're doing. All right. So a transformation changes a figure into another figure. The new figure that we get is called the image. Okay, so example, here's our original figure. After we transform it or change it into another figure, this, for example, would be called the image. Okay, so the specific transformation we're talking about, a translation, is a transformation in which a figure slides but does not turn. Every point of the figure moves the same distance and in the same direction. Okay, so now I want to point out your learning target. All right, so just kind of know this. I can translate a figure by moving every vertex the same distance in the same direction, which is what it just described, how it just described the translation. All right, that's how we translate something, by moving every point the same distance in the same direction. Okay, so first we want to be able to identify a translation. So they're asking us, is the blue figure a translation of the red figure? Are we just taking every point or every vertice and sliding it the same distance in the same direction to get the other vertice? So quick example, I'm going to try and draw this best I can. Here are the vertices, okay, of the red figure. Can I just slide every one of these? So here to here, its corresponding angle. Here to here, its corresponding angle. Here to here, and here to here. Can I just slide each of those vertices the same distance in the same direction to get this blue figure? The answer is yes. All right. Each of these lines, if drawn perfectly, are the exact same length. Okay. Each of these lines, if drawn correctly or perfectly, are the exact same length. Okay. Now, guys, you should be noticing that I can't do that here. Okay. I can't draw. If I tried, this would correspond to this angle right here. This would correspond to this angle right here. Right away, since they cross each other, they're not going in the same direction. Okay, so you should know that that's not a translation there. All right, but let's read this real quick. So in A, the red figure slides to form the blue figure. So yes, it was a translation. In B, the red figure turns to form the blue figure. So that is not a translation. It's actually called a rotation, which we'll talk about in another lesson. All right. So hopefully that makes sense. That's the easy part. I'll have you just kind of get answers for these three real quick in your head. So why don't you pause your video, get some answers, and then when you come back, we'll talk about it. All right, so number one, let's read this. Number one says, no, the blue figure is larger than the red figure. Okay, so this is a different type of transformation than we're talking about today. This is not a translation. Okay, can't be bigger. Number two, no, the red figure flips to form the blue figure. This is something called a reflection. So that is not obviously a transformation or a translation. Number three, yes, the red figure slides up and to the left to form the blue figure. So we can do what I did earlier, where I can draw lines from each vertex to the other, and it moves the same distance in the same direction. So that one was a translation. All right, now let's get into actually doing this. Okay. Now, personally, I think this is very confusing for you, so I'm just going to show you how to translate first in my own way. All right. But something you need to know, some vocab, how I'm going to be reading this. Okay. So where it says reading over here, this A with the little dash, all right, that is read as A prime. Okay. So like B with the little dash, that's B prime, and this would be C prime. Okay. Use prime symbols when naming an image. All right. So just so you know what we're doing, we're going to be taking something like this red triangle here, right? And the book is going to tell us how to translate that or how to move it. And we're going to perform that translation to get something like this new triangle. All right, where we're going to name our vertices as, for example, A prime, B prime, and C prime. All right, so we use these little dashes to name new vertices of the image, all right, which is, remember, the figure after it's moved or transformed, okay? So again, we're going to kind of skip this key idea here. It's confusing. So I'm going to show you something now, how to do this. A couple ways, all right? So example 2, again, we're physically getting into now actually translating one of these figures the way that the book tells us to, okay? So again, I'm going to show you 2 ways we can do this. All right, if we take, so it says translate the red triangle 3 units right and 3 units down. What are the coordinates of the image, okay? So first thing we can do, one way we can do this is take each of our vertices, our original vertices, and move them 3 units right and 3 units down, okay? So I'm going to try and draw this best I can, but 3 units right. So 1, 2, and 3, and then 3 units down. 1, 2, and 3. Here's my new A value, okay, or my new A coordinate or vertice, which, remember, I'm going to name it A prime, okay? If I do the same thing with B, 1, 2, 3, 1, 2, 3, here's my new B value, which I'm going to name as B prime. C, same thing, 1, 2, 3, 1, 2, 3. All right, my new C value is C prime. Now, obviously, in the end, we want to connect the dots, right, to make the triangle. So my new vertices get connected. There's my new triangle drawn pretty poorly, but hopefully that makes sense, what I just did. We're just taking each vertice and moving it the way the book says, okay? Now we want to name the coordinates of this, all right? So what I'm going to do, let me erase it and show you what the book does because it's a lot neater. Okay, so let's take a look. They did the exact same thing I did, right? We're just moving it three right and 3 down for each vertice. And then at the end, we want to actually, remember, we want to name what the coordinates are, all right? So it says, what are the coordinates of the image? That means the new shape, right? What are these coordinates? So they list them. A prime, what is this vertice's coordinates? 1, -2. B prime, what is that vertice's coordinates? 5, 2. And then C prime, what is that vertice's coordinates? 4, -1. Okay, so hopefully that makes sense. Next example, I want to show you a different way to do it, all right? So this extra example, let me show you a different way, all right? So we can always use the way that I just showed you, right? But here's another way we could do this, okay? What I'm going to start by doing is, you're going to see this in the next example a lot too. I'm going to name, you know what, I'm going to do this in red. Do this in red. I'm going to name each of these vertices by writing out their coordinates, okay? So bear with me here. My A, right now, it's starting at, if we look at the X values, they're going by 2's, and the Y values are going by 2's as well. So this is really at -2, -1. Okay, B. Where's my starting B vertice? It's at 0. It's at 0, 2. And where's my starting C vertice is at 3, 0. Okay. Here's what we can do. I'm going to change this now. I'm going to list out. This is A prime. So check this out. So I can find my new coordinates. By taking 2 units right. So they're telling us to move 2 units right. Which value represents horizontal movement? Our X value does. Okay, because when we move horizontally, we're moving along the X axis. Okay, that should make sense. So if I want to move 2 units right, I can find my new A X value by adding 2 to this original X value. So -2 plus 2 would give me 0. Okay, so my A prime's new X value is going to be 0 because I'm moving 2 units right from -2. Okay, let's do that same thing with B. So B's original X value is 0. If I moved this thing 2 units right, where would I end up? Well, I could add 2 to 0 to figure that out. I'd be at 2. If I added 2, the same thing, to this 3 where I started for C, if I moved this 2 units right, where do I end up? I'd end up at 5. Okay, let's do something, a similar concept with our y values now. All right, it's also telling us we're going to move 5 units up. Okay, which value in our coordinates, which value represents vertical movement? The y value does. Okay, because when we move vertically, we move along the y-axis. All right, so hopefully you can guess. What we could do now is we could take 5, because it's saying to move 5 units up, and we could add 5 to each of our y values, our original y coordinates, to get our new y coordinates. Okay, so if we add 5 to -1, that gives me 4. All right, if I take 5 and add it to my original y value here, which is 2, I get 7. Same thing, if I add 5 to 0, I get 5. Okay, so what I'm showing you, because you're going to do this on IXL on Thursday actually, is we could just add or subtract how we move horizontally to our x values, and add or subtract how we move vertically to our y values to get our new coordinates. Okay, and we could also draw our image that way. All right, so that's another way we could do this. Okay, there's 2 ways. That's the second way. So I'm going to briefly go through that again and show you what Big Ideas does. All right, so they're showing you that same method that I just showed you in this example. So they say the vertices of a square are A is 1, -2, B is 3, -2, C is 3, -4, and D is 1, -4. They're saying to draw that figure with those coordinates and then its image after a translation 4 units left and 6 units up. So let's look at, again, another example of what I just talked about. All right, so here are the original vertices they gave us in this sentence right here. The vertices of a square are, here they are. Okay, they listed them out just like I did before. Okay, now since it says move 4 units left and then 6 units up. Okay, since it says to do that, they're subtracting 4 from the x values. Okay, because it's saying to move left, right? That would be negative. So we're going to subtract 4 from the x values. Then it says to move 6 units up. We're going to add 6 to all the y values. So just like I talked about in the last example, we could find our new vertices by using this method, okay? Where we end up with A prime is -3, 4, B prime is -1, 4, C prime -1, 2, D prime -3, 2. What can we do with that information? Obviously, we can draw our figure, the original, and its image using these vertices. Okay, so instead of sitting on the coordinate plane and drawing those lines that I did in the first example, we could do it this way too. Okay, so knowing both ways is really important to be successful in these IXL benchmarks you guys are going to have in the next couple of days. All right, but at this point, let me just kind of show you what you're doing today. All right, so today, as your practice, you're going to go into Big Ideas and do your practice today. All right, so it's the 2.2 practice, a couple problems that wrap up everything we talked about today. Okay, hopefully this made sense. If not, ask questions through email or the discussion thread in Canvas, and otherwise I will talk to you guys tomorrow.